Good evening. Welcome to another edition of A for A levels. This is my tutor. Today we're going to do A levels maths. February, March 2021, paper 3-2. Question 1. Solve the equation of ln x cubed minus 3 equals to 3 ln x minus ln 3. So you're going to put both sides of the equation in ln, in one ln term only. Okay, so this 3 ln x minus ln 3 is ln x cubed. This 3, you move it up over 3. So x cubed minus 3 equals to x cubed over 3. Multiplying by 3, you get 3x cubed minus 9 equals to x cubed. X cubed equals to 9. X cubed equals to 9 over 2. And x is, we're only giving real numbers. So it's cube root of 4.5. The answer is 1.65 with 3 significant figures. Okay, next. Polynomial ax cubed plus 5x squared minus 4x plus b, where a and b are constants, is denoted by px. It is given that x plus 2 is a factor of px. So it is a factor px, p of minus 2 is equal to 0. And it's divided by x plus 1, the remainder is 2. So x plus 1, p of minus 1 is equals to 2. So p of minus 2 is a times minus 2 cubed. Minus 2 cubed is 8. So 8a plus minus 2 square is 4. 4 times 5 is 20. Minus 4 times minus 2 is plus 8. Plus b equals 0. So here we have 8a plus b equals minus 28. On the other side, minus 1 cube is minus 1. So here is minus a. Minus 1 square is 1. Times 5 is 5. Minus 4 times minus 1 is 4. Plus b equal to, so here minus a plus b equals 2 minus 9 is minus 7. Writing it here is easier to see. Plus b equals minus 7. Take away. 8 minus minus 1 is 9. 9a. B minus b cancel off. Minus 28 plus 7 is minus 21. A is minus 7 over 3. Substituting, you get minus 7 over 3. B equals to minus 7. Minus 7 over 3. B equals 7 times 3 is 21. Minus 28 over 3. Okay, solve. Next question. By first expressing tangent x plus 45 equals to 2 cot x as a quadratic equation in tan x, solve the equation x is between 0 and 180 degrees. So using the compound formula for tangent a plus b, you get tangent x plus tangent 45 minus tangent x, tangent 45 equals to 2 over tangent x plus 1. Okay, tangent 45 is 1, so tangent x plus 1 minus tangent x I think this is single fraction. One is tangent x over tangent x. Okay. So this is 2 plus tangent x. Cross multiplying, you get tangent square x plus tangent x equal 1 times 2 to 1 times tangent x is tangent x minus tangent x times 2 minus 2 tangent x plus, oops, is minus tangent square x. So rearranging, you get 2 tangent square x tangent x, this one you can cancel, plus 2 tangent x minus 2 equals 0. Simplifying, dividing by 2, you get tangent square x plus tangent x minus 1, 0. Now using the quadratic formula, minus 1 plus minus 1 square minus 4 times 1 minus 1. Get tangent x equals to minus 1. So 5 over 2 x equals to minus 1 minus 5. Okay, so this solution is (31.7°). Oops, this. Now this is in the second quadrant, so you must put in your so this is 180 minus 58.3 degrees. So finally you have your two solution, 31.7 degrees and 121.7 degrees. Okay, good. Variables x and y satisfy the differential equation. 1 minus cos x divided dx equals to y sine x. Solve the differential equation obtaining the expression for y in terms of x. So you must separate the variable. dy over y. Moving the y to the left hand side and moving all the x onto the right hand side. X, okay? So you integrate. Integrate 1 over y, you get ln y. Now 1 minus cos x, when you differentiate, you get sine x. So this is the integral of, you get ln fx. So this over here, this, if you know how to integrate, it is a one-step integration. So this is 1 ln. Seems to be hanging. Okay, good. Let's just do this. Okay. So this is ln of 1 minus cos x plus c. So the next step is to find what is c. So y is 4. So ln 4 x is pi ln 1 minus cos pi c. Cos pi is -1. So this will be ln 2. So c equals to ln 4 minus ln 2. C equals to ln 2. So rewriting all the terms, ln y equals to ln 1 minus cos x plus ln 2. Y equals, this will look like the first question that we did, but this involves more terms only. So y equals 1 minus cos x over 2. And that is the solution. Sketch the graph of y against x for 0 to 2 pi. So this equation will be y equals to half minus half cos x. So a minus cos x graph will be a reflection on the horizontal reflection of the x-axis of a cosine graph. So what I'm going to do is I'm going to draw first. So the amplitude of this graph is half. So it is moving up by half. Therefore, the graph will be up to here will be 2 pi. Here will be pi. Here is 0. This is 1. Okay, that's it. Express 7 sin x plus 2 cos x in the form r sin x plus pi. So this form of equation is very simple, where r and alpha is easily found. So r is square root of root 7 square plus 2 square. So this 7 plus 4 is root of 11. Alpha is up tangent 2 over 7. Let's find out this 2 over root 7. Decimal place, 37.09. So the answer is root 11 sine x plus 37.09 degrees. That's the solution. And solve the equation. Root 7 sine 2 theta cos 2 theta equals to 1. Above you have x, now it's 2 theta. So remember, so this is root 11. Sine instead of x is 2 theta plus 7.09 degrees equals to 1. Okay. Sine 2 theta plus 37.09 11. So 2 theta plus 37.09 equal. So this is a double angle. You need to move 2 cycles if theta is between 0 and 360, but it's between 0 and 180 only, so you don't have to. Shift sine over root 11. So this is 17.54 80 minus 17.54. Solving, you will get, okay, there's something interesting here. See this, you take 17 minus 5.54, you minus 37.09, you will get a negative value. So what you're going to do is you're going to take 17.54 after another rotation of 360 degrees. So it is 17.54 plus 360. So you're going to take away this answer. So solving, you get 37.09 plus 180. Oops, no. 180 minus 17.54 minus 37.09, and you divide by 2. 62.69 is the first solution. The second solution is 17.54 plus 360, 37.09. Divide 2. 170.2 degrees to 23 degrees. 170.23 degrees. Okay, remember, it's positive values. Positive value angle, not negative. Let fx equals 5a over 2x minus a times 3a minus x, where a is a positive constant. Express fx in partial fractions. So in partial fraction is 2a over 2x minus a plus b over 3a minus x. So you're going to find what is the capital A and capital B. So 5a, a 3a minus x, b 2x minus a. So let x equal 3. So you have 5a equals to 2 times 3a is 6a minus a is 5a. So this is 5ab. So b is 1. Let x equals to a. So you have 5a equals to 3a minus half a is 5 over 2a. A is 2. So expressing it as a partial fraction, you have fx equals to 2 over 2x minus a plus b is 1 over 3a minus x. Okay. Hence show that fx dx is ln 6. So that's the reason why you want to write it as a partial fraction. Okay? Because you want to write it as a fraction so that you can integrate 2x minus a 1 over 3a minus x dx. So when you integrate a fraction like this in the power of 1x, it's always a ln. So the coefficient of x is 2, so you'll be 1 over 2 ln x minus a. Okay, I forgot there's a 2 at the top. So it will be 2 over 2 plus 1 over, the coefficient x here is minus 1, on 3a minus x plus c. So your final solution is 2x. Oops, I forgot. No, plus c. This is a definite integration. Minus a. So it's minus ln a also, so it's over 3a minus x. A. So this will be equals to ln 2a minus a, 2 times 2a is 4a, 3a. 3a over a, you can solve minus, substitute with a is ln a over 2a. So ln 3 minus ln half is ln 6. That's it. Good. Next question is on vectors. Two lines have equation r equals to 1, 3, 2 plus s, 2, negative 1, 3, and r equals 2, 1, 4 plus t, 1 minus 1, 4. Show that the lines are skew. Okay. So this is a vector equation. Actually, R is basically a position vector x, y, z. So you have, when you want to show that the line are skewed, means the line does not intersect. So they do not have a common point. So the first vector equation gives you x equals to 1 plus 2s, y equal to 3 minus s, z equals to 2 plus 3s. The second vector equation gives you x equals 2 plus t, y equals to 1 minus t, z equals to 4 plus 4t. Okay, so equating the x, y, and z, you get the first equation 1 plus 2s equals 2 plus t. So you have 2s minus t equal 1. Equating the y, this is equation 1. 3 minus s equals to 1 minus t. So you have minus s plus t equals to minus 2. This is equation 2. Equating the third z, you get 2 plus 3s equals to 4 plus 4t. So you have 3s minus 4t equals to 2. Now solving equation 1 and 2. So 1 plus 2. And you're solving, there's only two unknowns s and t, so you need to use two equations to solve only. So you get s equals to minus 1. Substituting into the first equation, 2 minus 1 minus t equals to 1. So you have t equals minus 3. Now, if the solution of s and t is consistent, that means both lines intersect, it will be consistent. You will also solve for the third equation. So if we solve for the third equation, then they intersect. If they do not solve, then it's inconsistent. They do not intersect. So let's substitute into the equation 3. So you have 3 times minus 1 minus 4 times minus 3. So this is equals to minus 3 plus 12, which is 9. It's supposed to be 2. So solution inconsistent. Not intersect, or it is skewed. Okay. Find the acute angle between the directions of the two lines. So when you have a vector equation, r equals to a plus sb. A is your position vector, b is your directional vector. So we will use the directional vector of both lines. So the first one is 2 minus 1, 3. The second line is 1 minus 1, 4. 1 minus 1, 4. Okay, they want to find the acute angle, so you do a dot product. Equals 2 minus 1, 3. This implies between two lines, it's the magnitude. So dot product is 2 times 1, which is 2, plus minus 1 times minus 1, which is 1, and 3 times 4, which is 12. So the magnitude of 2 square plus 1 square plus 3 square, 9 plus 4 plus 1, which is square root of 14, times 1 plus 1 plus 16, square root of 18, cos theta. So you have cos theta equals to 2 plus 1 plus 12 is 15 over square root of 14 times square root of 18. So theta equals to, so normally before 2020, this question will come out in AS Math, AS Pure Math. So you're lucky for, it comes down now in A2. So you will have A2 Pure Maths where the, where the questions are a bit easier. Okay, so it's 19.1 degrees. It's the acute angle. 19.1 degrees. So there you have it. The next question is a question of complex numbers. So you rationalize the denominator, minus 4 plus 2i, 3 plus I. You multiply by the conjugate of 3 plus I. So you will get minus 4 times 3 is minus 12, plus 4i, plus 6i, plus 2 over 3 square plus 1 square. You have minus 12 plus 2. Minus 12 plus 2 is minus 10 over 10 is minus 1 plus I. So this is your answer, U over V. Express U over V in the form REI theta. Need to find the modulus and argument. So the modulus of U over V. So it's written U over V. So this is likewise the same as length of 2 points. So it is minus 1 square plus 1 square, which is root 2. So the argument, tangent, you have to be careful. The argument lies between minus pi and pi. So when it is minus 1 plus I, it lies in this quadrant. Okay, which is between pi over 2 and pi. So the argument of U over V is 1 over negative 1. Remember, this is pi over 4. In the second quadrant, it will be 3 pi over 4, pi minus pi over 4. Okay, so U over V written in the Euler form will be root 2 E I 3 pi over 4. Okay, there you have it. In an Argand diagram with origin O, the points A, B represents the complex number U, V, and 2U plus V. State fully the geometrical relationship between OA and BC. Minus 4 plus I. Okay, I'm going to write it down first. U equals to minus 4 plus I. V equals 3 plus I. U plus V equals to 2 times minus 8 plus 3 minus 5 plus 3I. Okay. So you have an Argand diagram. Real, imaginary. Hopefully I can fit all in. Minus 4 plus I. So this will be A. V is 3 plus I, so 3 plus I somewhere here, 3, okay. B is 5 plus 3I. U plus V. So it's somewhere here. C. O, A, and B, C. B, C. Oh, okay. So if you draw 2U will be 2 times U, like a vector. It's U and another U, and then V will be here. V will come back here. This is V. This is also V. So this is B. This is C. This is A. So state fully the geometrical relationship. They are parallel. And BC is twice OA. Okay, that's it. Prove that angle AOB is 3 over 4 pi. AOB, so this angle. This angle is the argument. This angle here. Angle AOB is the argument of U minus the argument of V. Okay, which is the argument of U over V. Argument of U over V. U over V is, let's see, 3 pi over 4. Which we have shown in A. That's it. At fx equals e to the power of 2x plus 1 or e to the power of 2x minus 1 for x larger than 0. The equation for x equals to fx has one root denoted by a, verified by calculation that a lies between 1 and 1.15. So you let x equals to x minus e to the power of 2x plus 1 over e to the power of 2x minus 1. So if g of 1 is equal to 1 minus plus 1 2 minus 1. So this gives you a negative value, minus 0.313. 1.5. So we are just merely showing that one is a positive and one is a negative value. Then we can conclude that the root lies between 1 and 1.5. So of course this definitely will give you a positive value, 0.395. So you can make a conclusion that x lies between 1 and 5. Okay. Use an iterative formula based on the equation in part A to determine A correct to 2 decimal place. Iteration in 4 decimal place. So the iteration will be xn plus 1 e to the power of 2xn plus 1 over 2xn. Okay. The first n is 1. The first, so your xn, put it between 1 and 1.5. I put it 1.2. Okay. So you have, I'll take it 1.2. I'm going to count it in my calculator. 2 times answer plus 1 over 2 times answer minus 1. So x2. So each iteration in 4 decimal place. So this is 1.1995. 1.1995. 1.1997. If your first approximation is near your approximate answer, then you will reach the solution very easily. So as long as this 2 does not change, so you can make your approximation. So it is 1.20 in 2 decimal place. Next question, find f prime x, hence find f. So this you have to differentiate. Exact value x for which f prime x equals to negative 8. So you have fx of 2x of 2x minus 1. F prime x, you're going to use the quotient rule. So this is e2x minus 1. So differentiating e to the power of 2x, you get 2e2x minus e2x plus 1. Same thing. Over e to the power of 2x this is equals to minus 8. I'm going to simplify. So this is 2e to the power of 2x. So this is 2e to the power of 2x. E to the power of 2x minus 1 minus e to the power of 2x minus 1 over 2x minus 1 square. Cancel this. So this is 2e to the power of 2x times minus 2 is minus 4. So this is minus 8 e to the power of 2x minus 1 square equals to 4 e to the power of 2x negative 2. Exact value. Okay, so expanding this, you get 2e 4x minus 4e 2x plus 2 minus e 2x equals 0. So you have 2e 2x minus 5e 2x plus 2 equals 0. Factorizing, this is 4x. 2x 2 minus 1. Okay. Now, so we have e2x equals to half x equals to ln half x equals to minus half 2x equals to ln 2 x equals to half ln 2. Let me see if there's two solutions. So you have to see a value of x is a positive value. So this is not the solution. This, you reject this solution. This is a negative value. So this is the solution. Exact value. So question also will give you a clue. Question 10. The diagram shows the curve y equals to sine 2x cos square x for 0x half pi and its maximum point M. Using the substitution u equals sine x, find the exact value area of the region bounded by the curve and the x-axis. So area pi 0. Sine x cos square x. So you're asked to use the substitution u equals to sine x du over dx equals to cos x u over cos x equals to dx. So when x is half pi, u is sine half pi, which is 1. X is 0, u is sine 0 equals to 0. So you have 0 u. This is, oh, sine 2x, sorry. This is sine 2x. No wonder. So sine 2x, I need to change a bit first. Wait. Let's do this. So I need to change. This is half pi. This is 0. So sine 2x is 2 sine x cos x times cos x will be 2 sine x cos cube x dx equals to, making the substitution, bringing the 2 out. This will be u cos square x cos x dx. So it goes 2, 10 u. This will be 1 minus sine square x. This will be du. 2, 10 u, 1 minus u square du. 2, 10 u minus u cube du. 2 u square over 2 minus u to the power 4 over 4, 10. 2, which is 1/4 times 2 is half. That's the solution. Find the exact x coordinate of M. So you need to differentiate. Y equals to sine 2x cos square x. Dy over dx equals to sine 2x. Differentiate cos square x is 2 cos x times minus sine x plus cos square x. Differentiate sine 2x is 2 cos 2x. Okay. A bit too much to the right. So this is sine 2x. It's 2, huh? Sine x cos x plus 2 cos square x cos 2x. Okay. Now to find the maximum point, dy over dx is 0. So minus 2 2x sine x cos x cos square x cos 2x equals to 0. So what I'm going to do is I'm going to change this to the double angle. So here, the first 2 sine x cos x will be sine 2x. Sine 2x times sine 2x will be minus sine square 2x. And 2 cos square x will be cos 2x. So I'm going to change the sign to a cos. So this is minus 1 minus cos square 2x plus cos square 2x plus cos 2x. Okay. So expanding this is minus 1 plus cos square x plus cos square 2x plus cos 2x. So this will be 2 cos square 2x plus cos 2x plus 1. No, it's not plus 1. It is minus 1. Minus 1. Minus 1 equals 0. No. This one you can factorize. One, here will be minus 1. So you have cos 2x equals to half. Cos 2x equals to minus 1. Okay. So you need to choose the correct solution only. So m is between 0 and half pi. M is between 0 and half pi. Here is 2x equals to pi over 3 minus 1. So 2x equals to pi. So here will give you your minimum point. This will give you your solution. So this is the answer. Okay, that's it. Thank you. If you like, subscribe to my channel. Like, if you want the exercise, put a comment, put your email, and I will email to you. Signing off.